about the energy, about different types of energy, will be presented by our next two speakers. Professor Debertolis, you already had a chance to hear him from the University of Trieste. And Heikki Savolainen from Finland, Sami. Let's hear what they had to offer to us.
Here I am again. And I'm here, first time. Okay.
Excuse me, Paolo, excuse me for interruption. We might get one rather important political figure here in Bosnia in a few minutes or maybe in 30 minutes. So we might have some additional security checkups here. So don't worry about it. It will be just another guy who will be joining the conference. So we'll just continue like nothing is happening.
Some president of something.
This is the most amazing research I made. In this research, we wanted to check out results of the researchers by Slobodan Mistrak in April 2010 regarding ultrasounds from megalithic structure in Visoko Valley. We also wanted to expand his research with a wide group of different instruments from more simple to high-end equipment. Next. You see Slobodan Mistrak doing his research. Next, please. Dr. Mistrak found ultrasound emission from this structure in Visoko Valley, on the top of the Pyramid of the Sun, on the top of the Ravne, or the Tumulus of Ravne, inside or Ravne's labyrinth. Next. He detected a continuous ultrasound presence with the same emission frequency, 28 kHz, and having the same shape by oscilloscope, in the central plane of the Bosnian Sun Pyramid, and also centrally to the plane on the top of the Tumulus of Ravne, and also in the passage sideways to the prehistoric underground compound of Ravne. So we settled to investigate ultrasound emission with the equipment used by our group, that's the research group, with other methods and instruments. But Slobodan was the first to understand the ultrasound emission from megalithic structure in the Visoko Valley. At the same time, we began a study of effects of this type of ultrasounds on the human body. Next, please. This is the group of the studios for this research. Next, please. We began to research ultrasounds on megalithic structure from the Pyramid of the Sun during winter 2010 and 11. As opening, we used a compounder to hear ultrasound radiation with our ears. Next, please. Please, the light. It's possible to close the light, switch off. Okay. This is the top of the pyramid during the winter. Me and Professor Lucas. Next, please. It's an instrument that possesses dynamic sound operating primarily. What is the compounder? I described the compounder now. It's an instrument that possesses dynamic sound operating primarily on the level and amplitude of sound with other electronic equipment which work with sound. The compounder operates on sound and ultrasounds. This instrument, built by our expert of our group, engineer Giorgio Battistoni, compresses ultrasounds in audible sound. So, you can hear the ultrasound like an audible sound, because the compounder transforms ultrasound in audible sound. You can hear the ultrasound. This is the equipment. Next, please. The scale of compounder is very simple, very cheap to build. There is no big instruments or very expensive instruments, but very good. It's allowed to discriminate different components of ultrasounds like in an orchestra. You can distinguish violin from altos with your ears. So you can hear the ultrasounds like music. Not only on the instruments on the display. You can hear ultrasound instead of seeing them on display of an instrument. This is the scale, very simple. Next. The sensor, supersonic sensor used has been manufactured by an American company. And having very advanced technology. The equipment contains high mechanic and electronic components integrated in the same silicon substrate. A further but important technical details is the assembly of the small microphone on the focal point of metal parabola. A little parabola, so as to collect the very style ultrasound waves most effectively. This is the schema of the chip. This is the ears and this is the microphone. Next. The compounder. How work compounder? Briefly, one part of the instrument generates a variable frequency thanks to a potentiometer, and from that frequency, the instruments withdraw the frequency received from the microphone. So, when you receive the 50 kilohertz in your hair, this equipment transforms into 10 kilohertz an audible sound. Okay, next. This is the equipment. Next. Now I described the instruments. The plastic container, battery, very portable instruments. To use the instruments, the parabola with the microphone must be aimed toward the direction to be examined. And by rotating the tuning potentiometer, ultrasound waves can be detected if present. If the waves are not present, it is possible to hear something. You heard in the headphone or recorder if it is connected. So you put the parabola towards the font of ultrasound. Okay, next. We began to analyze the top of the pyramid sun on the results by Slobodan Mizrak. In this period, from January to February of this year, the pyramid is covered with snow, but snow reduced other noises which came from the town of former people now. Now, at this moment, it is impossible to record something because there are a lot of noise from the town of Visoko and the people nearly the top of the pyramid. Now there are only workers on the top of the pyramid. On the top of the pyramid, there were always different wings, which were able to disturb recording a small amount. Not so much. This is the beam from the top of the pyramid, like in this design. Next. We found ultrasound emission on the West Plateau with a wide radius. We found ultrasounds. There are ultrasounds on the top of the pyramid, like Misdrak found. But in our detection from January until April, in 3 different rounds, we could observe a remarkable change both in precise point or precise point of detection of the ultrasound, frequency and inspection. The beam is 5-6 meter diameter. This is the location on the top of the pyramid where we found the beam of the sounds. Next, please. In January, the beam of ultrasound was very strong, in a radius of 15-20 meters out of the medieval fortress. Not inside nothing we found inside the medieval fortress. In February, the signal was very weak, but pure, because in February in Visoko there were a lot of snow. But pure and very particular. Its intensity was not constant, but modulated and sometimes even absent. In particular, during recordings in April, we found that the sound could stop for 10 minutes or so, and they reappear even with a very high intensity. And now I want to have to you the voice of the pyramid, please. This is the voice of the pyramid. Very amazing, yes. This is the sound of ultrasound. There are a lot of noise in this moment. But the characteristic of this beam was inconsistent. 5-6 meter diameter of beam. It can move in different moments in a radius of 15-20 meters. Strength of beam varies with different weather. This is a very important thing. When the weather change the beam. We use the rigid protocol to recognize it. This is the protocol that we recorded all the characteristics, the site, the time. So we have now a database. We began to analyze the tumulus. We went also to the tumulus of Ravne. We began to analyze the tumulus in April 2011. At Ravne tumulus, the phenomenon did not appear. Present the same extent, yet is seen much more discontinuous than the pyramid of the sun, but similar. In this area, we used 4 different operators to give no influence to our results. Me, Professor Krasovets Lucas, Dr. Acconci, and Mr. Berta. However, only one of them was able to detect the frequency coming from the tumulus. The detection was not located at the center of the plane, on the top of the tumulus, but it was discontinuous and located far from the center, in another location. This is me, Dr. Acconci, and Professor Krasovets. Next, please. In the labyrinth of Ravne, with the compounder, was disappointing. The research was disappointing. No unusual operation was detected except in the last part of the tunnel. The ultrasounds were very weak to study with the compounder, but present. It was necessary to study them with a different method, microphones and high-end recordings. Next, please. In this situation, I put towards the soil, the compounder, but received weak signal. Next, please. Many questions to solve at this point. Is there something that still works inside the pyramid? The next part of this presentation by Heikki, you will have the answer. But now I can say yes. Something is still working inside the pyramid. What? We don't know. How does it work? We don't know. What is the relation between peak frequency? Heikki will speak about this. Next. During the measures with the Semir. Next. We need an expansion. We needed an expansion method. With the compounder, we analyzed the beam ultrasound by qualitative method by our ears. We concluded that the beams has a primary constant carrier and the second carrier over the primary. A line constant and another modulated. We understood that it was important for a quantitative method to analyze complete ultrasound emission. Next, please. To confirm the results with compounder, it was necessary to use another more high-definition method of investigation. So we asked for help for a professional sound engineer. Heikki from Finland was the best choice to collaborate. Please, go.
Yes, thank you, Paolo. Yes, thank you, Paula, and hello everybody, and greetings from Finland, Helsinki. It's happy to be here, and first of all I have to apologize that I'm talking to you from the chair, but this is because of the length of the cable with the microphone. So please look at the pictures, and I think you don't want to see me anyway. Okay, so I've worked with the audiovisual field last 30 years doing concerts and studio recording. Thank you, Paul. Studio recordings and live mixing, and I heard about this research in Visakol 2005, and since that I have been a follower of the project. And read also the negative media and the positive media. But I was very interested in what is going on here. So last January I replied to Paolo's article about that thing what you just saw, about his and Rod Slobodan's research of the ultrasound things, and I was thinking about to make a very simple method as a studio sound engineer, a simple method to go further with these investigations. Sorry, I have a little flu, so I'll try to get over. The first high-definition audio-based ultrasound, I came here on May 27th, and I was guided, and I got a very special treatment from Zara Kandli and Ajin and Richard, the hosts here, and they showed me all the place, and I was, eyes very open that what the hell is going on here. And I was first very skeptic when I came here because of all the information about this, and but now I'm here and I'm happy of it, and I'm very happy to be among these great researchers and scientists who are also speakers in this conference. So about my method. The This is a frequency response from the Sennheiser, very high, professional, expensive microphone, which is mostly used for classical music. And as you can see there, the frequency response is starting there, but it actually goes there, and it goes until 50,000 hertz, so 50 kilohertz. And a few words about hertz. So if you are a newborn baby, you are, as a human being, able to listen and hear the sounds from about 20 hertz until 20 kilohertz. So this is our area of audible possibilities, if I can say that. Sorry about my English, I'm Finnish guy. Not finished. And the basic thing of the method to investigate ultrasounds is that if you have a sound, for example, 28 kilohertz, if you put it one octave down, so octave is a musical scale, and if somebody doesn't know what is octave, if I say ooh, ooh, don't worry, I'm not starting to sing to you. That is an octave. So if you have a 28 kilohertz sound, for example, ooh, this ooh, it's 14 kilohertz. So, and one octave down from 14 kilohertz is 7.5, and so on and so on. And that is basically the method what we were using to find out the ultrasound emissions, possible ultrasound emissions. And the recording equipment was, I saw today somebody had the same machine here, recording, the Zoom digital recorder. And then the NTI, this is from courtesy of Finnish Broadcasting Company, made for audio measurements. It's a spectrum analyzer. And also the Sennheiser microphone, I had a pair of them with me, and that was basically the recording equipment used for my first trip. And the idea of checking the ultrasound was this. Is first just record the sound. Actually, in Ravne Tunnel there is no sound; it's silence. So when you're recording silence, you have to have the best possible equipment and with the best signal noise duration. It means that, you know, before the basic noise of the equipments are coming, there is 130 decibels of space for recording things. And the recorded sound files were high precision files, like you can see there, the sampling rates, and they were analyzed with the Pro Tools digital audio workstation, which is widely used all around in the world. And the system, like you can see there, it's possible to record until about 50,000 hertz sounds. And the method was actually to record those files, in Ravne Tunnel case, the silence, and then digital bars step down 3, 5, 6 octaves to get possible ultrasound signals to audible. And that was the basic method. It's widely used in music business nowadays with a good and bad way. So this is a sample of it, how it's done and how it's heard. the actual process. So here is your first visual and then the audio. That's the basic noise in the Ravne Tunnel. And just, you know, this is sound of silence, but amplified. And you can see here, here the bass is very powerful. And this so this means that you heard the change of the 3-octave down very speedy, and this is what it makes to a high end. So this is high sound and this is low sound, basically. And the cure. This is basically it's a normal. There's nothing special in this figure and this curve, except that the bass level in this is 10 Hertz, if I can see right. Yes, this is 10 Hertz. The very low, this is infrasound, and here is ultrasound. The level of the infrasound is, it shouldn't be so high in a place like Ravne Tunnel. Because I have been recording in Finland. I don't have the examples to show you now here, but I can show it later if somebody is interested. But I have been recording in Finnish forest, a sound of silence, because Finland is a very silent place. There is hardly anybody living there. And and also I've been making recordings in my studio, which is a very silent place, but not so silent than Ravne Tunnel. Ravne Tunnel is a very special place because it's actually it's like unechoed chamber in a way, and it's the basic noise level there is about 18 dBs. And as a comparison, if we are going to Isako Central Main Street, the noise levels are there about 70-80 dB, so it's a huge difference between the sound levels. Okay, then I have another example with the method of combination with Paolo's compounder system and my system, the audio system, and sounds like this. Now I think that we can hear only left channel because we can't hear the sound of the compounder. Because this curve here is the sound of the microphone, and this red one is from the Paolo's compounder. And these sounds here is tuned 3 octaves down. So you can see here peaks from the Paolo's compounder. But these peaks are, this is about 10, 20, 40, this is about 80 kilohertz, this peak, so they are very high. But this is the method to combination of compounder and Paolo's system and my system. This is recording from top of the Sun pyramid. Then we go back to Ravne.